Works projects, which are exploratory. These ideas are really early stage, and we sponsor them directly inside XLabs. So we've talked about some of the key themes. We don't just pick any idea, but we do try to align them against some of these strategic themes for the company. So with that background, I'm going to talk about 3 projects that we're doing in collaboration with partners, and one that's exploratory. Okay. So we have a project that is in tandem with a partner, NGD Systems, and this is exploring a brand new technology called computational storage. This is one of our partner co-innovation projects that's in flight, and this is a really significant project because there's a movement toward bringing compute to storage. As the amount of data proliferates due to IoT and video use cases, particularly at the edge, there's a need to bring the compute closer to where the data is generated. And this is even true inside a host. Instead of moving all that data from storage through the main CPU and back, the new model that's emerging around dense data is computational storage, where you have a compute node that's directly on the storage device itself. So here we see an NVMe device that NGD Systems produces, and here in the middle of it, you see an ARM processor, an A534 core with 8 gigs of RAM, running its own instance of Debian Linux. That OS instance has direct access to all the storage on the device without needing to bring it through the PCI bus to your main CPU. And what we're doing with this project is we're actually testing it in tandem with our Greenplum parallel database structure. So we're running instances of Greenplum nodes on these ARM processors across a set of up to 15 devices. This allows us to run the Greenplum database with its integrated analytics directly on storage, completely freeing the host CPU to run the application and other functions. This is great at the edge where you have limited host CPU and you want to maximize that, and this offloads it to the storage device and allows you to get more parallel compute capacity. Rounding it out, we're exploring in this project the ability to use BitFusion to actually GPU enable these ARM processor-based instances. So BitFusion operates by sharing GPUs across the network. In this case, the network actually flows between a VM that runs on the host, the x86 host, and it actually creates a network connection across the PCI bus by encapsulating TCP over NVMe. And in that way, these Debian instances running on the NVMe storage devices become separate computers on the network, and they can actually talk to the BitFusion server. So now you have a storage device that believes it has a GPU locally, and the Greenplum database can actually leverage that to do ML inference-based parallel queries running entirely on the storage fabric inside a host. So this is a really disruptive new approach for edge analytics. It increases data density, and it leverages core VMware technology such as BitFusion and our pass-through technology as well.
Scale